artificial intelligence.
Can get started with generative AI.
Artificial intelligence, or AI.
Generative AI.
Something's wrong.
Let's talk about artificial
Intelligence. No, 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 no.
That was weird. Welcome. Artificial intelligence is a subject I've been teaching for years, but in the past I often encountered this roadblock where people were willing to recognize AI was important, but, somewhere else, or for someone else. They could agree it was important for the company, or important for that big external project. It just didn't seem relevant to them as individuals. People would often tell me they didn't expect to personally use AI in any significant way in their own day-to-day work and life. But that belief changed at the end of 2022.
ChatGPT reaches 100 million users in 2 months.
AI could automate 300 million jobs.
It'll change the way we think and work.
It's coming for our jobs. Here's the 10 roles AI is likely to replace.
ChatGPT is banned in Italy over privacy concerns.
It's a malevolent AI and should be destroyed.
ChatGPT is about to revolutionize the economy.
We have never seen this level of interest in AI, or this level of anxiety. Incredible enthusiasm mixed with equal amounts of apprehension. Where's this all going? What's going to happen next? Well, that's what we're going to cover. This is a short introduction to artificial intelligence, or AI. And we'll talk about these latest AI-driven tools like ChatGPT, Google Bard, DALL-E, and others. Tools we can use to generate new content, whether that's text or images, audio, video, computer code. I'm going to show you what these tools are good at, what they're not good at, and why they're not good at certain things. But to really understand these most recent tools, we do need a little history, because they didn't appear out of nowhere. They're the latest in a long evolution of artificial intelligence that goes back decades. So we'll quickly go over that timeline and get the background we need. Along the way, we'll explore the most important ideas about AI and a lot of the vocabulary. Terms like machine learning, deep learning, neural networks, generative AI. We'll talk about large language models and foundation models and more, and what all of it means. But this isn't just about learning a few definitions. It's about recognizing where AI can fit, where it can make a difference. So we're not just going to talk about the ways it might impact your company or the projects you're working on, but how it's going to impact you personally, because it will. It is already, directly or indirectly, and it will continue to do so more and more. And I get it. You know this. So let's dive in. And we'll begin with a very common question, but it's one of those questions a lot of people don't want to ask. What exactly is artificial intelligence? What does this term even mean? Is there a basic definition we could learn, and from that point on easily say, okay, that is artificial intelligence, but that is not? And as strange as it might sound, the answer is no. There is no simple, agreed-upon definition that will always let us make that distinction. However, the question, what is artificial intelligence, is still an excellent question, and it's a great place to begin. Artificial intelligence is often talked about as this ultra-modern, cutting-edge, futuristic area of technology. And okay, it can be, but it does have a long history. I have a few textbooks here about artificial intelligence. This one is 30 years old. This one's 40 years old. This one's nearly 60 years old. Because this has been a serious field of study since the 1950s. But even back then, they admitted this term artificial intelligence is kind of tricky. We might want a simple, straightforward definition. We're not going to get one. For example, in this paper on artificial intelligence, which was written in 1958 by Marvin Minsky, who was one of the major researchers in the field, he co-founded the AI lab at MIT. And I'll summarize just 2 sentences of this: that it isn't useful to lay down an absolute definition for intelligence or intelligent behavior, for our goals in trying to design thinking machines are constantly changing. You see, the problem with this term, artificial intelligence, isn't that the words are difficult. We know what artificial means, we know what intelligence means. The problem is the goalposts keep moving. You see, across the entire history of computing, we've always had new goals, new aspirations, problems we wanted to solve, but we didn't know how. And some of these goals were considered so difficult, they really didn't seem possible without genuine intelligence on the part of the computer. These goals included things like, will a computer ever play chess at the level of a grandmaster? Can a computer ever recognize faces or understand spoken commands? Now, sure, we know how to do all of those things now, but what always happened is as soon as anyone figures out how to accomplish a goal, the response then becomes, well, that's great, but that's not really intelligence, is it? The computer isn't actually thinking, it's just executing a formula. It's just a computation. There's even a name for this. We call it the AI effect. And a lot of tech we now use every day began as some kind of artificial intelligence research. But as soon as it becomes actually implemented, practical, and out there in the world, nobody wants to call it AI anymore. There are tasks you can do on your phone that a few years ago would have been considered remarkable, incredible implementations of artificial intelligence. As just one example, we have facial recognition that's so fast I can turn myself into a 3D cartoon in real time. Now, if you'd shown this at an artificial intelligence conference 10 years ago, you would have been the star of the show. These days, most people wouldn't call this AI. It's just a cute thing you can do on your phone, if you even care. So we're not going to worry about getting to this perfect definition for AI. However, we do need a way to at least broadly categorize what are the kinds of things we typically call artificial intelligence as opposed to regular conventional computer programming. But we have to be careful. Because AI has been around so long, not just as an area of research and development, but also in movies and TV and books and games, we all have ideas and preconceptions about what artificial intelligence is, what it's capable of, or what we think it should be capable of. You can't help it. It's just part of the culture. There are cliches about AI that have become so pervasive that everybody just becomes numb to them. I'm going to show you a few of those cliches because some of them are useful and some of them get in the way. Artificial intelligence as a subject has a lot of common cliches and preconceptions, the things that everybody kind of knows about this. There's even visual cliches. For example, have you noticed that in our current culture, artificial intelligence has a color? Apparently, we all think AI is blue. Now, if you're thinking, Simon, what are you talking about? Let me prove it. I'm about to do an image search for the term artificial intelligence. We'll gather pictures from all over the internet that have been given this title or associated with this idea. There are thousands of images created by countless different artists and designers, but they are strangely consistent. It's as if there's only two ways you're allowed to show AI. You either need a wireframe image of a brain made of nodes, little dots with interconnecting lines. Your other option is a robot, but not any robot. It needs to have a white plastic face and, for bonus points, exposed head wiring. So let's see. I go to images.google.com and I search on AI. And we get node brain, white-faced robot with exposed head. It just keeps going. And notice, almost everything is blue. And this isn't just true for images on the web. You'll find the same thing with book covers and articles and presentations. It's like all the graphic designers had a secret meeting and agreed, well, AI is blue, obviously. And okay, I'm poking fun at this, but there is a point. When you begin to notice these cliches, and the next time you see a book or an article about AI, and right there at the top is a big blue image of a robot with a creepy doll face, you think, okay, I've seen this cliche before. What other AI cliches am I about to get? Now, some cliches can actually be useful. They give us starting points and ideas to talk about. But I find these kinds of images everywhere, it just isn't helpful. It's distracting because they don't represent what we're typically trying to do. I mean, I don't know what you're going to do next with AI, but if I had to guess two things you're not trying to do, I don't think you're trying to model a human brain, and I don't think you're trying to make a robot. And okay, both of these ideas, brain modeling and robotics, are genuine active areas of AI research. But it's not what most businesses are focused on. It's not what most businesses or individuals care about. So you won't be getting any more node brain or white-faced robot images from me. But I did say there's also useful cliches. So let's touch on perhaps the most common one you find in movies, TV, and novels, and that's the idea of an AI that operates at the level of a person. When artificial intelligence as a subject has a lot of common cliches and preconceptions, the things that everybody kind of knows about this. There's even visual cliches. For example, have you noticed that in our current culture, artificial intelligence has a color? Apparently, we all think AI is blue. When artificial intelligence is featured in movies, TV, games, books, it's usually a character of some kind. Sometimes that AI character has a body, whether humanoid or machine. Other times the AI is running on some massive computer behind the scenes. But it's typically shown as being capable of complex, multi-layered conversations, similar to and possibly higher than the level of a human. And where it isn't just capable of one or two specific narrow abilities, but it's generally intelligent. These fictional AIs can reason, they have multiple skills, and they're capable of learning new things by themselves. And this idea takes us beyond the term AI and into what's called artificial general intelligence, or AGI, sometimes called strong AI or full AI. Now, let me be clear. AGI is still hypothetical. It's theoretical. It only exists in fiction. We don't have AGI yet. We may never have it. But we do have available is a kind of AI sometimes called narrow AI. Now, this is often extremely powerful and can outperform a person, but it typically works in one specific narrow ability. For example, we have AI right now that could play chess better than anyone in the world. We have other AI that's wonderful at identifying objects and images. We have AI that can scour massive amounts of data and provide insights about that data. But just because one of these AI programs might be superb at detecting a spam email or be really good at recognizing an abnormal heart rhythm, it doesn't mean that same program can also play chess and compose a sonnet and recommend the next TV show to watch. And that's okay. For the most part, what we want is specialized intelligence, narrow intelligence. Because if we're trying to use AI to accomplish or understand something in particular, it's okay if that program is task-specific. Now, the latest generation of AI tools, like ChatGPT and Google Bard, one of the reasons they've made such an impact so quickly is they are more generally applicable than anything we had before, where you can use them to accomplish a wider and more flexible set of tasks. For example, you might use ChatGPT to help you write a resume, but it isn't just an AI that writes resumes. It's not that narrow. It's capable of much more. You might then paste in some complex computer code and ask ChatGPT to explain it to you. You could then ask it to create a packing list for your trip to Alaska, and then to summarize a business article, and then write a poem about quantum mechanics. It's very powerful, it's very flexible, but it is still narrow AI in that what it's capable of generating text content in response to direct prompts. ChatGPT isn't capable of reasoning or independent decision-making. So despite some clickbait headline articles you might see about these new tools and whether we've reached AGI yet, the short answer, no, we haven't. You might describe these tools as a step in that direction because they are more generally applicable, but we're still a long way from AGI. Now, a little later, I'll show you some specific examples of how easy it is to reach the limitations of what these tools are currently capable of. Now, if you're wondering, okay, so is anybody trying to develop artificial general intelligence? Oh yes, there's billions being invested in it. For example, OpenAI, the company who make ChatGPT, their goal, their mission as a company is artificial general intelligence. You find the term AGI everywhere in their own descriptions of what they do and what they're trying to do. Another example, DeepMind, owned by Google, is very clear that their long-term aim is also to develop artificial general intelligence, or AGI. So yes, there's a lot of activity, effort, and investment around this. But even if we don't have AGI right now, we do still have some very impressive AI. So let's talk about one of the ways AI is being implemented today, and that's using machine learning. Over the past few years, the most common, most successful, most practical approach to implement AI has been with machine learning. And it's led to some confusion about those terms. Machine learning and artificial intelligence are mentioned together so often it can sound like they mean the same thing. They don't. Artificial intelligence is a broad and sometimes vague term that we could basically consider all the various different approaches and methods that people have used to make a computer program do something smart. And machine learning is a set of specific techniques to do that. But machine learning is not the only way to implement AI. Machine learning, or ML, is a type of AI. It's a subset of it. All machine learning is artificial intelligence, but the broader field of artificial intelligence does include other techniques than just machine learning. But if you want to understand what machine learning does, let's first consider a normal computer program that doesn't use ML or any kind of AI. You see, in regular conventional computer programming, which includes most applications on your desktop or your laptop or your phone, a software developer tries to solve a problem by providing a bunch of rules and very specific instructions. If this number is greater than that number, then add these two things together. If this date is less than that other date, generate this error message. If the position of the asteroid on the screen is now the same as the position of the spaceship, then play boom sound effect and display game over. Now, make no mistake, conventional rule-driven computer programming is fantastic when you know what all the rules are and you can cleanly define them. But with machine learning, you don't begin by trying to figure out and define all the rules in advance. Instead, you begin by gathering examples to learn from. Here's what I mean. Let's say I wanted a computer program that could take a small digitized image and be able to recognize handwritten numbers, handwritten digits in that image. Well, let's make it even simpler. Let's say I want to write a program that could recognize the number 3. Now, if I take the conventional programming approach, I might try writing code that would take each image and look at every individual pixel one by one, figure out if it's light or dark, and then try and envision and describe all the different ways people might ever write a number 3 in this grid. Sometimes it's straight, sometimes it leans to the left or to the right. Sometimes the top loop is smaller than the bottom loop, etc., etc. And that would be the conventional programming approach. Figure out all the rules, go step by step, try and envision every possible eventuality. And to be clear, it would be very hard, tedious work, and with this particular problem, extremely easy to get it wrong. Now, if we instead take the machine learning approach, we don't begin by trying to figure out all those rules in advance. Instead, we begin with actual data, real data. In this case, the data would be thousands of different images of a handwritten number 3, and we use that data to build our program. And before doing anything, first we need to clean and prepare the data, make sure there's nothing extra, nothing missing. If I'm trying to teach a computer to recognize a number 3, then I don't want this data to also include images with a 2 or a 4 or some other character. I don't want blank images. Now, once the data is cleaned and prepared, we take all of it and feed it into a machine learning algorithm in a process which is called training a model. And after we've trained the model with all that data, we could then expect to be able to take a new piece of input, a new image, pass it over to that newly trained model and have it evaluate. Does this new image look like a 3 or not? We've provided enough examples that it could recognize the characteristics of that thing. And this is one of the tasks machine learning is very, very good at: classification. And it doesn't just apply to images. Classification is used with all kinds of data because it's a very common problem in computing. To get some new data and be able to ask, what is this? When we've got incoming emails, could we quickly classify them as these ones look like spam and these ones look legitimate? Machine learning's ability to categorize or classify helps in all sorts of situations. It's used for diagnosing medical conditions, fraud detection, evaluating social media comments. But classification isn't the only area where machine learning can help. There's a few other kinds of problems it's very good at, including regression, where we'd still begin with data to analyze and learn from. But instead of using that data to classify or categorize things, with regression, we use the data to predict a number of some kind, like an amount, a price, or a time, some kind of numerical value based on analyzing all the other data that might affect that value. Now, a classic example of regression is using it to predict a house price based on multiple other factors like square footage, number of bedrooms, location, age of the house, etc. But in agriculture, you might use regression to predict crop yields based on multiple other variables like the type of crop, the current weather conditions, the soil quality. If we had prior data about medical procedures and patient characteristics, we could then use regression to make better predictions that for a new patient having this procedure at this age with these comorbidities, what is the likely length of their hospital stay? Regression and classification are two of the most common applications of machine learning. There are other things we can do with it, like clustering and anomaly detection, but that's outside the scope of this course. If you're interested in knowing more about machine learning, I do have a course just on that that goes a little deeper. But there is a catch. Machine learning can only work if you have data to learn from, and not just a little bit. You need a lot of data and good quality data. This is why there's been such a focus on data collection and big data in the business world over the last few years. Because if you haven't gathered enough data, you will have nothing for your machine learning algorithms to learn from. In any machine learning situation, there's two essential pieces. First, you need data, which you have to provide. But you also need this machine learning algorithm that's able to learn from that data. And often people wonder, well, that sounds like the difficult part. So do the software developers in my organization have to write this machine learning algorithm? And no, most organizations don't write and don't need to write machine learning algorithms. You can just find one that's already been written and feed your data into it. It's the same way that if you want a database, you would choose an existing database management system software like Oracle or SQL Server, even Microsoft Access. If you want to make a website, you would choose a web framework or a hosted service. So here, when you're using machine learning, you typically use an existing machine learning platform or machine learning framework. There's lots of them, both commercial and open source. There are cloud-based machine learning features available in Microsoft Azure or Google Cloud or Amazon's AWS or with IBM. And with any of these, you can then pick and choose from a bunch of different machine learning algorithms depending on the data you have and what you're trying to do. And this is what's made applied artificial intelligence just blow up in the last few years. It's become so easy to get started when you don't have to build all this background infrastructure from scratch. But even though you don't have to write the algorithms yourself, you have to do some work. You can't just throw all of your corporate data at a machine and expect it to magically make sense of everything for you. Think about it this way. Let's say somebody handed me a flash drive with a year's worth of extremely detailed website activity data. Information about every single visit, what that person did, what pages they visited, what terms they searched on, how long they spent, what they clicked, did they purchase anything, did the order actually go through? Now, this data almost certainly contains information about fraudulent purchases that we might be able to use to help recognize and prevent future fraud. But this same data also contains information about high-value customers in a way that we could recognize new ones. And it probably also contains useful information about identifying hacking attempts. It's all in there somewhere. So first and foremost, we have to deeply understand what is it we're looking for right now? What are we trying to train the machine to learn? And the most important part of the entire machine learning process is preparing your data, understanding what it is you're looking for, and then filtering your data, cleaning it, labeling it, throwing out the stuff that's not relevant for this particular problem. Because if your data is full of garbage with invalid values, missing values, conflicting information, it doesn't matter how good the machine learning algorithms are. As ever in programming, garbage in, garbage out. Now, if your organization has a team of people working on machine learning projects, this is one of the responsibilities of the data scientist role, of transforming the data into something meaningful and usable for machine learning algorithms. And after that, choosing the correct algorithm, applying it, configuring it, testing it, that's another part that takes time and attention, and very importantly, understanding what you're trying to accomplish. Most data scientists would tell you it isn't a single task, it's a process where they'll often experiment with trying several different machine learning algorithms and test them to figure out which algorithm gives the best results for that particular problem with that particular data. And machine learning has been one of the massive successes of AI, with widespread adoption across a range of industries and applications. And even this latest generation of AI applications like ChatGPT, Google Bard, and DALL-E, they are all types of machine learning. Yes, they're more advanced than just simple classification or regression, but they're built on the same foundations. So let's talk about some more advanced aspects of machine learning. Earlier, I talked about the visual cliche of the wireframe brain. I even dismissed it by saying, most of us using AI, we're not. In any machine learning situation, there's two essential pieces. First, you need data, which you have to provide. But you also need this machine learning algorithm that's able to learn from that data. And often people wonder, well, that sounds like the difficult part. So do the software developers in my organization have to write this machine learning algorithm? And no, most organizations don't write and don't need to write machine learning algorithms. You can just find one that's already been written and feed your data into it.